let's go to page 52, and this is section 5.2, and this section is about number bases. So we're used to decimal system. So if you have 7, 9, 6, 5, 8, 4, 1, so this is the unit digit, this is the tenth, hundredth, and so forth. Okay, so this number is kind of long, so I'm just going to forget about this. I'm just going to focus on this. So this number is equal to 1 times 10 to the 0. Okay, and this one is equal to 4 times 10 to the 1. Okay, and this one is worth 8 times 10 to the 2, and this one is 5 times 10 to the 3. Okay, so again, this is in the thousands digits, so it will be times 1,000. Okay, so with this in mind, that if you go to example 5.1, okay, example 5-1, so you have 3, 4, 5, 6, another number over here tells you this is a base 7. Now by default, when you don't see a number, means it's base 10, because that's the one we've been using. Okay, and so you want to convert this into base 10. So this number is worth 6 times 7 to the 0 power. This number is equal to 5 times 7 to the 1 power. This number equal to 4 times 7 to the second power. And this is worth 3 times 7 to the 3 power. Okay, so now you just have to work it out. So this one is equal to so 3 times 343 plus 4 times 49 plus 5 times 7 plus 6 times 1. Okay, so you notice 1, 7, 49, 343, right? So you just keep multiplying by 7, and this will equal to 1266. Okay, but this is kind of cumbersome way to do it. That's an easy way to do this. So whenever you're going to convert to base 10, this is what you do. So you got 3, 4, so give a little bit of space, 5, 6. So if you're going to use, so whenever you're going to convert to base 10, so what you do is you put the base, your original base over here, and use a synthetic division. Okay, so drop the 3, multiply, you add, multiply, okay, you add, and then you multiply, and then you add. Okay, and this number will give you that. Okay, so use the synthetic division, and you also do the backward ways. Okay, if you want to convert anything into any particular base, so let's use this example. Okay, so if you want to convert, so this is base, so equal to 1266 base 10. Okay, so again, when you have the different base, so like base 7 convert to base 10, just use synthetic division, divide by 7, you get that. Okay, now if you're going to go the other way, since this is keep multiplying, then what you do is you want to do the dividing. Okay, so if you're going to convert this into base 7, so you want to convert this back into that. Okay, the way you do it is you go and do the long division, and you want to start from the right side, you want to go that. So you go 1266, you divide by 7. So if you're going to convert to base 7, you divide by 7. If you're going to convert to whatever base, you just divide by the base. So if you're going to convert to base 2, then you divide by 2. If you're going to convert to base 8, you divide by 8. Okay. So divide by 7, you're going to get 1. You're going to get 5, 6, 8. Okay, drop the 6, and you go, and this is going to be 0, right? Okay. Now you see the relationship between them. Okay. So this is just reverse of that. Okay. Then after that, you're going to put 180 down here. So this number is going to come down here now. Okay, so this is your digit. Okay, see that? So this is your digit, and this number is right over here. So you're going to divide by 7. Okay, and then Okay, and divide by 7. So 14, you drop, okay, and 5, 35, then you subtract 5. You can see that 6, 5, see the 6, 5. So the remainder would be your digits. Okay, so now you go to the next one. So you can bring these things down. 25, divide by 7. Okay, you see that? So 6, 5, 4, and see the 3. So then you keep dividing until you cannot divide it anymore. Okay. So there will be 0. So keep going until you get 0. Okay, so 0, and then you're going to get 0, and you get 3. So you get 3, 4, 5, 6. That's how you get that. Okay. So again, from different base, convert to base 10, you just use synthetic division. From base 10 to any base, you just keep dividing, and you go from left to right, and whatever your remainder will be your digits. So 6, 5, 4, 3. See that? Okay. And keep going until you get to the 0. Okay. Now let's go to example 5.2. Okay, so you have 216 and you want to do it in base 4. Okay, so that means you want to divide by 4. So 216 divided by 4. So be 5. So 20, so 16. 4, 16. So your remainder is 0. Then you bring these things down. So 54, bring it down here. Divide by 4. So 1, 4. So 14, 3, 12. So your remainder is 2. Okay. So now I can bring these things down. 13 divided by 4. So it's 1. And then you bring the, so the last one you can see that it's going to be a 3. Okay. So 216 is equal to 3120 base 4. Okay. Okay. Now, what if you want to convert this into base 2? Okay, let's go and convert this into base 2. Okay, it's not on the example, but we're going to do that, and there's a reason for that. So, 216, you want to convert into base 2, right? So, let's go ahead and do the division. So, 216 divided by 2, so you get 1, 0, 8. Okay, and you divide by, again, so 5, 8, okay, and you divide again, okay, okay, divide, keep dividing. Okay, so 216 is equal to 11011000 base 2, okay? And 216 is equal to 3120 base 4, okay? Now what's the relationship between these? Well, the relationship between these is that you can, so if you want to convert this to this or to this to this, you don't want to go through all that. You got to realize that 2, so 2 equal to 2 to the 1, 4 equal to 2 to the 2, okay? So that means every one of these digits equal to 2 of these digits, okay? So in other words, if you're going to convert this to these, you divide into 2 digits. Again, base 2, because this is the square of this, exponent of this. So this is, so every one of these digits will equal, because this is square of that, so one of these digits equal 2 of this digit. So if you divide these things up like this and use your binary, so 0, 0 is 0. Now remember, this is, so the 4, right? So this will equal to, so this be binary, so 0, 1, so this is 2, right? Again, you have to know your binary. So this is worth 1, and this is worth 2. So 1 times 2 is 2. So this is 2. Again, look at your binary. So this is 1, okay? And this is 1, 2, so it'd be 3, okay? You see that? So that's how you convert. So again, so because this is a square of this, so every digit of this equal to 2 of this digit. And when you're going backward, okay, if you're going to go back, okay, so if you're going to, so this is a base 2, and this is base 4. Now, if you're going to convert this back to that, again, every digit equal to 2 digits. 0 in binary is 0, 0. 2, okay, it's going to be 1, 0, okay. Because in the binary, right, you go 0, 1, okay, and then you go 1, 0, then 1, 1, and you carry over to 0, 0, 1, right? Okay, so this your 0, 1, and this is your 2, and this is your 3, and this is your 4. So you got to know your binary. Okay, and 1 will give you 0, 1, and 3 is 1, 1. Okay. Now with that, okay, now notice that base 8 equal to 2. Base 8 equal to 2 to the 3 power. Base 16 equal to 2 to the 4th power. Okay. So you can convert back and forth between base 2, base 4, base 8, base 16, back and forth. Okay. So the key to, so let's say if you want to convert, so let's go and use another example. So let's say if you are 3120 base 4 and you want to convert into something base 8, okay? So how are you going to do that? Okay? Well, one way you can do it is by convert to use a synthetic division, get into the, so use a synthetic division to get into the base 10, and you go and use long division to divide. But if you notice that the relation between them, you can go and do the shortcut. So you can go and convert this into base 2. So base 2, right? So let's do this. So 3120 convert into base 2. So every digit equal to 2. Right? So now you got 11011000, right? Now to convert to base 8, remember 8 is the cube of 2, so it means every 3 digits. So this is base 2. So every 3 digits equal to 1 digit of that. Okay? So they're going to give you 0. So this is worth 1, this is worth 2, so this will give you 3, and this will be 3. So they give you 3, 3, 0, base 8. Okay? Now, how about if you're going to convert into base 16? Okay? How are you going to do that? Okay? Now, since 16 is square of these, okay, that means the 2 digits of this will equal to 1 digit of that. But this is kind of hard to figure, okay, because 20 base 8, base 4 is kind of hard to understand. So it's easy if you're going to use the base 2. So again, we already got a base 2 here. So 1101100, right? Because this is base 2, so 16 equal to 2 to the 4th power. So it means 4 digits of this will equal to 1 digit of that. So you convert, so cut it into 4 digits. Okay, so now this is what? So this 1, 2, 4, 8. So this is equal to 8. So this is 1. So you kind of have to keep track. So 1, 2, 4, 8. So this is 13. Okay, so how are you going to get the digit 13? Well, in base 16, what I do is you start with 0. You go 1, 2, 3, 4, 5, 6, 7, 8, 9. And after you go A, B, C, D. So this is like a 10, digit 10, 11, 12, 13, 14, and F is 15. Okay, so once you go F, then you go becomes 10 again. So 13 will be D. So this is going to equal to D8 base 16. Okay, so that's how you kind of convert things kind of quickly back and forth. Okay. So if you go to page, again, if you look at page 53, Okay, so base 16 is called the hexadecimal or hexadecimal. And again, hexadecimal is used a lot in computer. Also, binary, the base 2 on the bottom of page 53 is used in computer also. Okay, so now let's go to example 50, page 54, the example. So page 54, example 5-3. 5-3. Okay, so you're going to add in binary. So you got 1 0 0 1 1 1 0 base 2, and you're going to add. Okay, and make sure none of the digits. So I'm going to go backwards. So you got 1 0 1 1 0 0 1 1. So make sure none of the digits carefully. So you're going to add. Okay. Now when it's base 2, you only can use 0 and 1. As soon as it hits 2, it carries over. Okay. So 0 plus 1 it gives you 1. 1 plus 0 gives you 0. Now 1 plus 1 is 2, but because it's base 2, that means it's like a 10. So you write 0 and you carry 1. Okay. And so 1 and 1 is like 10 already in base 2. So 1 plus 1 is 10, plus 1 is 11. So you write 1, you carry 1. So 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 1 is 10. Right? Think about binary, right? So 1 plus 1 is 10. So write 0, you carry 1. 1 plus 1 is 10. Okay, so that's that in base 2. Oh, wait, this 1 plus, sorry. 1 plus 0 is 1. Sorry about that. Yeah, got carried away. So be careful, because with a lot of 0 and 1, it's very easy to get confused. Okay? So again, 0 plus 1 is 1, 1 plus 0 is 1. And 1 plus 1 is 10, write 0, carry 1. 1 plus 1 is 10, plus 1 is 11, so write 1, carry 1. 1 plus 0 is 1, 0 plus 0 is 0. 1 plus 1 is 10, so write 0, carry 1. 1 plus 1 is 10. Okay, so that's that. And now, if you want to convert this to base 10, I can use your synthetic division. So you got 1 0 0 0 1 1 0 1 1. So there are different ways we can do this, okay? Because depends on how many digits are there. Because this is worth 1, this is worth 2, 4, 8, 16, 32, 64, 128, 256. Okay? And so when you add, this will give you 283. So that's one way of doing it. Another way you can do it is, again, using the synthetic division. So 1, you drop, multiply, you add, 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 multiply, you add. Going too fast. Okay, again, you get that, right? I kind of like the synthetic division. I think it's a little bit quicker, because this one you kind of count and you have to add. So it all depends. By the way, some calculator can help you to convert to base 2, 8, and 16. Okay, so some calculator can convert back and forth between 2, 8, and 16. You also need to know how to add different bases. For example, here's another example on the bottom of page 54. You have 235 base 7 and 114 base 7. So to add, okay, so 5 plus 4 is 9, So it's 2 over than 7, right? So you write 2 and you carry 1. Again, 5 plus 4 is 9, is 2 more than 7. So you write down the remainder 2, you carry 1. So 1 plus 3 plus 1 is 5. So it's below, so it's okay. 2 plus 1 is 3. So it becomes 352 base 7.